Hello and welcome back to CS1322. Today we are going to cover lecture number 2. This would typically be the second lecture if this was a Tuesday-Thursday class of the first week of class. So this is the last lecture of the first week effectively. I'm going to go over a couple of quick things to make sure that you guys are keeping up with everything and just a few logistics before we get too far down the road here. So over in D2L, if you haven't noticed by now, under quizzes, you should have 3 quizzes that are available to you right now. The first of them is a syllabus quiz. The second one is a policy quiz. For both of these, you have unlimited attempts to do them, but you have to eventually get a 100 on them. So these are prerequisites for the course effectively. And then quiz 1 is also available to you down the bottom, and that one is an actual quiz. Please remember that the quizzes combined, of which there will be one a week pretty much, the quizzes combined are worth 25% of your grade. So it is important that you complete quiz 1 before August 30th, and you do need to complete the syllabus and the policy quiz before August 23rd, which is about, I guess, a week away from now. So that's that. Hopefully in the course homepage on D2L, you have also started to dig around a little bit and found the books, which are labeled off of here. There's the Java book and also the Fundamentals of Computer Programming with C. Those are also listed off the resource page on the FYE site over in ccse.kennesaw.edu/FYE. So you can see the books are labeled down here linked to down here as well. The slides are also in here if you haven't found them on the FYE site. Other than that, hopefully you guys are doing pretty well and you're enjoying the videos and keeping up. Today we are going to talk about classes from a review standpoint. Again, this is all material that was covered in 1321, so hopefully none of this is too new for you, but just in case you had some hard times with it or you've forgotten it, we're going to go back over basic fundamentals of how classes work and how objects work. So without further ado, we're going to talk today about defining classes. We're going to talk about constructors, including the default and how to overload a constructor. We're going to talk about class instance variables. These are variables that would be in the object that each individual object would have its own copy of. We're going to talk about making methods public or private and whether they return or not. And also, we're going to talk about setters and getters for the private variables. So inside of these slides, we have lots of code. And what I did was I went ahead and took that code and stuck it out on my REPL site, just starting off here with a blank main class, where I just have the usual hello world. And then I pasted in the definitions of the trophy, which is simply what's on these slides. And I'm just going to do that so that I can actually run the code and show you stuff. Today in REPL, I'm doing this in C# instead of doing it in Java, just to switch things up and make sure that the folks who are in the class for C# don't feel left out. So we're going to alternate back and forth, but as we've said many times, the language really doesn't matter here. The syntax is going to be almost identical, and when it's not, we're going to call it out. And the example in this particular slide is here where we use a private string. Whether the string is lowercase or uppercase tells you whether you're in Java with uppercase or C# in lowercase. Other than that, this code would actually paste directly into into a Java compiler and would work just the same. So if I run this, as you can see over here, I simply get hello world, which is what I would expect to get because my main function does nothing other than print hello world. The definition of the class that's down below is there. It's been made, but it doesn't actually do anything because I'm not using it in any way. There are the content of a couple of different slides in here. So let's talk through this block of code first. And this is with regard to defining a class. So what is a class? A class is the definition that is used when you instantiate an object of that class. So in this case, we are making a class that is of type trophy. Trophies like what you get when you win a contest or whatever. So the trophy would have some kind of name. Perhaps it might have number of points that you got when you got the trophy. in some point system. I don't know. This is an example. It is what it is. And then in this block of code, we have two constructors that are listed. The default constructor is listed here first. I keep doing that. And it is simply a default constructor. It takes no arguments. There is just an open and close parentheses at the end of the method name. The method name must match exactly to the class name in order for it to be a constructor. And if this were not here, if we simply removed this block of code, the object or the class definition is still completely valid. It just will do nothing when you instantiate the class inside of your main program or wherever it is. And sometimes that's a problem because, for example, maybe when you instantiate a class of a trophy, you have to have a name for that trophy. Maybe you don't, maybe you do. But that's why in this circumstance, we're going to override the constructor. We're going to give it two separate definitions for a constructor. One that takes no parameters and just sets name and points to pretty much some arbitrary string. And then a second constructor, which takes two arguments. One argument is a string, which is of type n, and the other argument is an int of, a string called n, and the other argument is an int called p. And those are just simply going to be the name and the points, and we're going to assign them. So a couple of things here. We haven't really talked about strings much, and we'll cover them in more detail. But at a very high level, a string is a sequence of characters which are held together and passed around as a single thing. So we talked about the char type, char, and that is a single character. A string is pretty much a set of characters that are passed around together. There's lots of detail about strings that we're going to cover later, and you've probably seen them before in your previous class because string is a pretty simple topic. So you can ask for the length of the string and so on and so forth. The integer that we're passing in for p here is nothing more than a number. Okay, so the key point of this slide is a constructor is a piece of code that runs every time the class is instantiated into an object. You can have a default constructor. Even if you don't write it, it is always going to be there. It does nothing if you don't write it. If you do write it, it will take no parameters. You are overriding the constructor with no parameters. And then you set whatever it is that you want to set inside of there. You can have more than one constructor, in which case you can have different arguments and different parameters to that constructor. And then with those arguments, you will use them to actually update information. So why do we have these constructors? Well, this class definition contains two private variables. We have name, which, as I mentioned, is a string, and we have points, which is set to 10. Both of these variables cannot be modified outside of the object. So in order for us to be able to set them, because we have declared them as being private, we have to have a way to actually do that. So if I were to instantiate trophy inside of my main code and then try to say trophy.name equals, I'm going to get a compiler because name is defined as a private variable. It is not accessible outside of the class definition. So if in order for it to ever be updated, I either have to create getters and setters for it or change it during the initiation of the object through a constructor. All right, so that's that slide. We're going to go over here and we're going to talk a little bit more about the overloaded constructor. So in this case, we are taking in two parameters, n and p, as I mentioned. We can name these whatever we want. Their name is completely arbitrary. N is a terrible name, first off, because it's not very descriptive, as is p. But you can see how they got there, n for name, p for points. Inside of the constructor, we are just calling the variable that is part of the object. All right, so if we go back and we look, we have a private string name and we have points. And down here is where I have my overridden constructor. That is exactly what's on the slide. Again, this is just a copy and a paste of what's on the slide. So as I say, these can be anything. This could be Fred, and this could be Bob, which are even worse names. And here's Fred. It would need to be updated here. and Bob would need to be updated there, and everything would be exactly the same as it was before. That is completely valid. The only thing that I would say that you need to be careful about is if you name these parameters the same as the name of the variable that is used in the class, it will cause confusion. So an obvious choice would be name and points. However, note that there is already a variable called name that is defined in the class, and now I'm defining a variable called name in this method. And so what would you actually write here? You would pretty much end up saying name equals name and points equal points, and that doesn't make any sense. The compiler has no idea what you're talking about at that point. Do you mean this name? Do you mean that name? I don't know. So if you were going to do that, you would have to say this.name and this.points equals name. The this keyword indicates that you are referring to the class variable, not the actual method variable. And now everything should compile and be fine again. Okay, so you can name it whatever you want. This naming it the same as the variables that are in the class is probably just unnecessary. Just call it something else. New name, for example, new points, and now all of a sudden we don't have to do this crazy of using the this. It is perfectly valid to use the this. It does remove the ambiguity, but you can avoid it by simply picking better names, right, or different names. And again, that should compile and be fine. All right, so that's the idea of an overloaded constructor. You can have more than one overload. You could have a constructor that only takes the string for the name and sets points to 0. You could have a constructor that only takes the points and sets name to I don't know. So you could have as many different constructors as you might need to have. One with one variable, one with 2, one with 3, one with 4, whatever it is that you needed. All right. The next topic that we're going to talk about here are the need for getters and setters. So because our variables in this block of code or in this object are declared as private, as I said, I cannot change them outside of this block of code. So just to prove that point, up in my main, I'm going to go ahead and create an instance of this object. So I'm going to say trophy, we'll call it participant, or participation, equals new trophy. All right, and as you hopefully remember, that's how you would instantiate this object. So far, hopefully no syntax errors. It just complains that I made a variable and I've done nothing with it, which is okay. But now we're going to go ahead and say participant, RTION, dot name equals enda. And this is not going to work. And the reason that it's not going to work is because it is inaccessible due to its protection level. I declared that as a private name. I then went and tried to set it, and it said, no, you're not going to be able to do that. So how do I go about setting that name? And the answer is that I need to create a getter and a setter for it. So in most languages, Java, C#, in your IDE, there's probably going to be a button for creating all the getters and setters. In this IDE, there isn't, so we manually created them. But the getters are nothing more than methods inside of the object that specify what it is that you are trying to do. So for example here, we have for the variable points, we have a get and a set that we're defining. For the get, we're simply just returning the variable points. For the set, we're checking to make sure that what they gave us was greater than 0, and then we're updating it to that value. All right, so value is an implicit word that the setters understand in C#. In Java, you're actually going to pass that in as a parameter, and you're just simply going to create a method called set points, probably in this case. So what is the point of these getters and setters? So, I mean, what have I achieved by marking this variable as private and then turning around and giving you a method for updating it? That seems very counterintuitive. Why all this unnecessary stuff? Couldn't I have just come up here and said, okay, fine, they're public, and now all of a sudden I could update them? And yes, you absolutely could do that. The reason for the getters and setters is you may have some things that you want to check and validate before you allow them to get or set. In the case of set, it's the more obvious one. So we here want to make sure that they never set the points to less than 0. If we declare the points as a public, then they're able to come in and set it to negative 4,372, and that's fine. But maybe that's not what you want. And from a consistency standpoint inside of your object, you want to make sure that everything in there needs to be how you need it to be. There are some cases where a negative number is not valid at all. So, how many miles is it from point A to point B? The answer cannot be negative 15. That's not a possibility. So you should make sure that your variables are being checked correctly, and you're only allowing the user of your objects to actually set them appropriately. And that's done by having a setter which you check all of the parameters. In the case of the getter, sometimes you might want to return something more than just the points. You might want to return a string that always says you have 17 points, or you have 19 points, or you might want it formatted in a particular way. That would be an example of a getter. You could also have things that you check, and you may refuse to return the answer under certain circumstances. For example, you may have a permission that you want to look through and make sure that the user has permission to get that information, which that's plausible. All right, so here is the code again. All I did was copied and pasted that over. All right, so the next thing we're going to talk about is overriding a common method called toString. Both Java and C# have this method in every object. It's an implicit method that is always there. You actually get it through inheritance, but we'll talk about that in a little bit. But toString is used anytime that you attempt to use the object as if it were a string, which the most common scenario of doing that is if you print out using your print statement in your language, which in this case is going to be console.writeLine, the object name. So I'm going to take this out because that was causing a compile error, and instead I'm going to use this so that I don't have to be bothered retyping it. I'm going to move it down here, and I'm simply going to print out participation. Let's see what we get. We get, the reason that we get that is because I've actually already overwritten it. Like, that's weird. Why did I get that? Let's comment this out for just a moment. Okay, so all we got back was the word trophy. Just maybe not very useful. So to be clear, what I did here was I instantiated a new trophy, and since I didn't pass it anything, that trophy would have called its constructor that has no parameters, and it would have set name to, yeah, that's a problem, and it would have set points to 0. And then when I said print trophy, which that's a weird thing, right? What does print trophy mean? It doesn't. Print car, print airplane. I don't know. I have no idea what that even means. But here I am calling print on it effectively, and it returned the word trophy, which is just the name of the class. But maybe that's not what I wanted to do when I ask for the information about the class. So that's why I might want to override the toString object. So to be clear, what's happening here is I am replacing the code for toString with a new block of code. And that new block of code will do whatever it is that I wanted to do, which in this case is I wanted to return the name and how many points there are. And these are just the variables from the class that I'm pulling out. And you'll remember that the plus operator is used if you need to concatenate two strings. So the weird syntax here is I'm returning the name, which is a variable, concatenated with a string, and a string here has double quotes around it, with a space and a open parenthesis in it. That's a weird string. And then I'm concatenating the value of the variable points, and then finally I'm concatenating a closed parenthesis, and that's just so that I get a set of parentheses around the number of points. And again, obviously this is just formatting. It doesn't really matter. I got, yeah, that's a problem, and the reason I got that again is because that is what the default constructor set the name to, and the number of points is 0, and again, that's because that's what the default constructor did. I've done nothing to this object, so that's what I'm going to get. All right, so just to prove a point, I'm going to recreate my object here, but this time I'm going to pass it 2 parameters. So the first parameter I'm going to pass it is best coder, and that's going to be worth 15 points. So This time when I instantiate the object, I'm not calling this constructor, I'm calling this constructor. Why and how does it know that that's what I want? Well, because I passed it two parameters. The first parameter was of type string, and the second parameter was of type integer. And it looks through all of the various constructors and says, well, that doesn't have a string and an integer. Oh, this one does have a string and an integer. Therefore, this is the constructor that it means for me to call. So when I do this same exact program, or when I run this, you'll see that this time I get best coder and 15. Now, you may be thinking, isn't this an awful lot of work to print out the words best coder, parenthesis 15? Yes, it is. This is just an example. Obviously, you could do more complex stuff in these constructors. All we're doing is setting two variables. That is a typical thing that happens in a constructor, but there might be many other things that you might get to do with the object. So it's important that you understand the concept, even if this is a very trivial example. All right, so that is overriding the toString method. This code is identical in, this code in Java is written slightly differently. You just say @override, and then I think all the rest of that is identical. Is that true? toString is lowercase. It starts with a lowercase t instead of an uppercase t. And other than that, we are identical. All right, so that's how you override strings in the two languages, or override methods in the two languages. All right, so hopefully that makes sense. We're going to play with this just a little bit. We're going to go ahead and call one of the getters just so that we can see how that works. So if I wanted to get back the name of the trophy and just the name of the trophy, I will effectively be doing name as a get. All right, and in this case, all I would do is I would say participation, which is the name of my object, dot name. And since this is returning a string, I'm going to go ahead and print it out. And I'm just going to turn this one off so that there's less confusion for a moment. So right now, the only thing that is going to get printed should be the name, which is best coder. And the reason it's best coder, again, is because of the way that it was instantiated. I could also get back the points. And I get back 15. So I think that's pretty simple as to how you use that. If I wanted to update the points, then I would simply say and then just to prove the point, I will print it out again. And so it was 15 the first time, and it was 17 the second time because I updated it to 17. So when I'm doing that, that is implicitly using the setter that is defined in there. And just to prove this point, you will notice that we didn't create a setter for name. We only set a getter. So I'm going to try and set the name of the object as well, and you're going to see that's not going to work. It says, yeah, no, I can't do that because you don't have a setter for that. Okay, the reason it said that is because I forgot the semicolon, but you're actually going to see the real error. Property or indexer trophy.name cannot be assigned, it is read-only. All right, and that is because I did not define a setter. All right, so that's getters and setters, and hopefully that's pretty clear. So the second topic that we're going to cover today is we're going to talk about arrays. And again, this is probably something that you have talked about before. There are obviously many different types of collections in both Java and in C#. Arrays are probably the simplest of them. We spoke in the previous video, or in video number 1, about a variable. A variable is effectively what I called it is a bucket where you can store some piece of information, and it has a particular type of information that it allows. The downside of a variable, especially if the variable is of a primitive type, is that it can only store one thing. So what happens if I want to store 2 numbers, or 3 numbers, or 17 numbers, or 4 million numbers? I could make a separate variable for every single one of those, which would be terrible. Please don't do that. I mean, if it's 2, then that's fine, but if it's 12 or 15, then you shouldn't be doing that. An array is effectively a set of buckets that are all of the same type. So instead of there being a single bucket, you can have an array of 5 buckets, and each of those buckets can hold an item that is an integer or a character or an object of some form. So hopefully you've seen this before. One thing that's interesting about arrays is that they are created with a size. When they are created with that size, they are locked into that size for life. So in this example on the screen, which I'll give you more detail on in a second, this 10 in here represents that the array is of length 10. And that means that it can only ever hold 10 things. If you try to put an 11th thing in there, you will get an error. Once they are defined, they are locked in space. They are locked into that space. So it is important to remember that you create the array big enough that for what you want, but it's also important to remember that when you create an array that's super huge, all of the memory that is necessary gets allocated at the time that you create the array. So whether you use it or not, it's going to chew up memory. And again, if you're storing 15 numbers and you make the array 16, life will go on. But if you have to store 10 million numbers and you make the array 5 billion, that may be the difference between the program running and not running on somebody's computer because of how much RAM they have. So you shouldn't be just setting things to these infinite sizes and then crossing your fingers that no one will ever need 1,000,000,001 in that. So arrays are not always the right choice, but they are something that you should be aware of. There are other data types that we're going to talk about in the next module that allow you to grow and shrink dynamically, which are a little bit more useful. But the concept of an array exists in every language, and they are always set in size. So this is not unique to C# or Java. It's actually true in, as far as I am aware, every single language. So how do you go about creating an array? Well, the answer is, I'm going to get rid of the thing that is causing a compile error and make sure that I compile before I am adding any more crazy to this. All right, so if we wanted to define an array in here, we'll do an array of integers to start off with. So we would say int, and then we put a pair of square brackets. That pair of square brackets indicates that this is going to be an array. So very specifically, by what I have typed so far on the screen, I am creating an array of integers. That means that there will only be integers in this array. I now give it a name just like anything else. So this is a type, just like a bar, just like a bool or int or double or float or long. This is just another type. It's an array type by putting those square brackets in there. So I'm going to call my integer array numbers because that's descriptive. And if I do that by itself, that defines the variable, but it does not actually make any space available for the variable. So that's a very important thing to remember here. When you create an array, there are two things you have to do. You have to define that you are going to make an array, and then you actually have to allocate memory to it in order to be able to use that array. And the way that you do the second part is that you say numbers equals new int 10, or however big you want the array to be. If you do not do this second statement and you try to push things into the array, you're going to get errors. Because even though you said you want an array, you never said how big of an array you wanted. And until this second statement is completed, the computer does not actually allocate any space for you, so there's no way for you to put things into that array. All right, so that should compile. It says you created something and you never used it, which is true. So how do I put something in there? I simply say numbers at position 0 equals 7. And bada bing, there we go. Can I print that out? Sure. Print it out the same way, numbers at position 0. And a semicolon before I get yelled at. And hopefully, if I actually had put the S on there, that will not produce an error, and I get back the number 7. I should probably comment out these other things that are printing things to the screen, because that's going to get confusing here in a minute. All right, So just to prove a point, we just get a 7. Okay, so if I wanted to put something in the third cell, I would say numbers at position 2 equals whatever value. So it is important to remember that all arrays in all languages are indexed from 0, not from 1. So if you say numbers at position 1 equals 9, that's not actually putting it in the first cell, it's putting it in the second cell. Everything is indexed from 0, you just need to get used to that. It is confusing sometimes, and it will probably mess you up at least once or twice, but it is always indexed from 0. So that's that, and I absolutely could continue putting numbers in here. I need to call it numbers, not number. Number at 9 equals 22, and so far everything should be hunky-dory. All right, what happens if I try to say numbers at 10? Well, I'm going to get an error. Why did I get an error? Because I said I wanted it to be of size 10, and I tried to put something into 10, because see footnote A. All arrays are indexed from 0. So yes, it gave me 10 cells, but they are numbered 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The last cell is numbered 9, it is not number 10. In order for this to work, as written, I would have to change the size of the array to 11 to allow me to put something into the 10th space, the cell numbered 10. All right, so that's arrays, very simple. They can also be of objects. There's no reason that they have to be just integers. So what we're going to do here is we're going to get rid of, well, let me point out that int is also arbitrary. I could have done an array of booleans, I could have done an array of floats, an array of doubles, an array of longs, shorts, any type that you want. An array of strings is a common one as well. All right, so we are going to change this up. I'm going to go ahead and comment all of this out. You'll remember that a comment string is either 2 slashes to comment out one line, or it is /* if you're wanting to comment out a block of code. Please note that you cannot embed /* inside of /*. So if you turn off one block of code and then you try to turn off something bigger outside of it, you need to remove the inner /*, otherwise you'll get weirdness. What will happen is the closing /* will be marked as the end of the comment, and then later on you have a trailing /* somewhere. So it will very much confuse the compiler. Most IDEs, including this one, will do something to indicate that you have commented it out. In this case, it grayed it out. That's why it is much lighter. All right, so I'm going to turn this on again, and we are going to go ahead and create an array of trophies, because I am so cool, I get all of these trophies and I need to be able to store them somewhere. So I'm going to create an array, I'm going to call it my trophies, and I'm going to allow myself to have 10 trophies. How do I do that? Well, it works the same as it did when it was an integer. The only thing that's different is we say trophy, we put in our square brackets, I'm calling it my trophies, and I'm going to say they get new trophy of size 10. Now you might say, well, that's different than what you did last time. It is. I'm doing the 2 statements in one line, which is perfectly valid. This, what I did down here, and this that I did up here are 2 different syntaxes for achieving the same thing. In this case, I'm doing the definition and the creation in one line. In this case, I'm doing them in 2 separate lines. There is no difference to the compiler. It could care less which one you do. Some people like one, some people like the other. You can also do them at different times, so you can allocate the memory later after you've defined it at the top of a block of code if you needed to do that for some reason. All right, so this creates for me an array of 10 trophies. If I compile, the type trophy does not contain a constructor that takes 1 argument. Yes, I'm sorry. Those are supposed to be square brackets, not round brackets. There we go. They're square brackets because I'm making an array. They would be round brackets if I was trying to actually create the object with a constructor. All right, so that made for me a, I was wondering why am I getting output, and it's simply because it's never commented that line out. That gave to me an array of 10 trophies. So what can I do with this? Let's start sticking trophies in there. So your good instinct might be to say my trophies at position 0 dot name equals best in show. And that all seems very reasonable, but it's not going to work. Why not? Well, because I have an array of objects, and I did create the array, and I allocated the memory for the array, but each of those objects still needs to be instantiated. What's inside of the array in this case needs to be instantiated. Why did I not have this problem with the integers? Well, because they're primitive types. I don't have to do that for a primitive type. But just like at the very top here, where I instantiated a single object, which I called participation, each one of the objects that is in my array also have to be instantiated. So what I would actually need to do is say my trophies at position 0 gets new trophy. And this time it is the parentheses because I'm actually instantiating an object. And I'm still not allowed to set the name because that's not a thing that I'm allowed to do. So let's go fix that for just a moment here. Let's go ahead and create a setter. And I'm just going to set it to the value. So it is, what is it? It's name equals value. And again, value is a magical keyword for a setter. All right, now it should work. Okay. So I have created an array that can hold 10 trophies, and in the first cell, which is called cell 0, I have instantiated an object, and I have set the name of that object. I'm going to go ahead and give it a number of points. Set it to 10. And then I'm going to go ahead and put something into cell number 1, and I'm going to do that one ever so slightly differently. I'm going to say my trophies at position 1 equals new trophy, and then I'm just going to actually pass the constructor the two variables. So the same as before, when I'm creating an individual object, I can call the constructor either the implicit constructor that does nothing, or if I've overridden the implicit constructor, then it'll do whatever I told it to do, or I can call another constructor that takes in parameters. So again, this line here is identical to what I did at the beginning when I instantiated the object. The only thing that's different is instead of just putting it into a single variable, which is what I did up here called participation, I put it into one of my cells in my array of trophies. So I now have an array, and that array has 2 trophies in it, and each of them has a name. So how would I print one of them out? Let's take a look at the name of my second trophy. I would say console.writeLine, and I would pass it my trophies at position 1, because I want to look at the second one, dot name. And you would think. Okay, and what I got back from that was best hair, because that's what the name of the second trophy was. All right, so that's how that works. So what happens if I try to access the third trophy? So I'm going to say console.writeLine my trophies was right at position 2, which is the third one. So what do we think is going to happen here? Well, I've never assigned anything to that second cell, and I've also never instantiated an object there. So what will the print do? Well, it'll bomb pretty badly, and it will say you just can't do that. You're trying to make a reference to something that is not an object, because that's what I'm trying to do here. I'm trying to talk to a cell which is defined as being of type trophy, but I've never actually put a trophy there. So I'm asking for something that's impossible. There is nothing there, and as a result, it fails. To be clear, it did actually compile. You note that the program ran, and it actually gave me best hair, which was the output of this line. It's only when it got to this line that it crashed. So there's a distinction between something that the compiler can tell is wrong versus a circumstance where you did something in the code that is going to ultimately cause an issue. This caused an issue because I tried to reference something that is not there. It didn't know that at the time of compile. It is perfectly plausible that something else set that trophy before we get here, in which case that statement may be a valid statement. So syntactically, this is a correct statement. I am asking for something that is well within the bounds. If I ask for trophy 11, it knows that's impossible because I defined it as being of size 10, so the compiler will throw an error in that circumstance. But the fact that I'm asking for something in a cell that I previously said will exist, that's on me to make sure that I made sure that there is something in that cell before I go ask for something in that cell. And later on, we're going to see ways where you can check to make sure there's something there before you print out the name, which would be nice, because otherwise you are going to crash the program, which is not a great user experience most of the time. But I wanted to point that out because sometimes people get confused by that. There is a big distinction between a compile time error and a runtime error. Some of them, some errors that you may make are noticeable by the compiler, others are not, but they're still errors. It is wrong to try and access that cell when there is nothing in there. So there is that. All right, so just out of, just to do something, what we're going to do is we're going to create a new method inside of our main class here to go look for a particular trophy by name. All right, so we have this array of trophies already, and I want to be able to look through those trophies and find a particular trophy. So I want to know how many points that trophy is worth, for example, or maybe I just want to know where it is in the array because I may have a function that's needing to find that out. So let's say I just want to know where it is in the array. So to be clear, I'm making a new method. That method is going to take in the array of trophies, and it's also going to take in the name of a trophy that I want to look for. And it's going to go through the array and try to find any trophy that has that name. Very specifically, I'm going to say I just wanted to return the first trophy that has that name, because of course it is possible I could set the same name on multiple trophies. So just for the sake of this example, we are looking for the first instance of that name inside of my array. So this is not a trivial thing to do because I can't just use some built-in function to search through the array and look for something, because this is an array of trophies, which I just made up. So because I'm dealing with a class here, I'm going to have to write this method myself. And that's fairly common that you will have to write a method to go look through an array for something. And it brings us to the thought of needing to iterate through an array to look for something inside of that array. So without further ado, we're going to start off. We're going to say this is a private static method. It's going to return an integer because that's going to be the position inside of the array. And I'm going to call it find trophy. All right, so I said it's going to need to take two parameters. The first parameter is going to be our list of trophies that I'm going to have to pass it, because this function, or sorry, this method might need to be called multiple times with different arrays of trophies, because I may have my trophies from baseball and my trophies from football or something. I don't know, making up an example here. So how do we take in a parameter that is an array of trophies? Well, it's the same as what we did when we defined an array of trophies. This is an array of trophies, because I said so, trophies, open, close, square brackets, and I'm calling it search list. And then we're going to take in a string, and we're going to call it target name. This is the particular thing that I am looking for. All right, and we're going to put in some curly braces around that. Okay, so what I need to do is I need to go through every cell in the array, and then inside of that cell, I'm going to have an object, and what I need to do is I need to pull out the name out of that cell, and then compare it to my target name, and if they're the same, I need to return the current index. That's the logic of what we're going to do here. So to me, this seems like it's going to be a for loop. It's going to be a for loop because I know how big the array list is, or at least the code knows how big the array list is. I'm going to ask it that inside the for loop. So I'm going to say for int I equals 0, I less than, all right, so I have a search list array. And all arrays have a property called length, which tells me how big they were defined. Not how many things are in there, but how big they were defined. So when I created this array, back up in the code a moment ago, I set it to 10. This is going to return the number 10. So I'm going to say search list, which is the name of the parameter that I'm taking into this method, dot length. And then I'm going to say I++, because I wanted to increment. So again, from the for loop, setting I to 0, which is the first cell, I'm saying while I is less than the length, keep incrementing I. So that should all be familiar from the previous class. If not, go back and watch that video. And then what I want to check is if search list at position I is null. Okay, what am I doing here? Well, so if I don't do this, it is going to look in cell 0, cell 1, cell 2, cell 3, cell 4, cell 5, all the way up to cell 9. Because the for loop is going to keep going. And it's entirely possible that I won't be able to just exit when I find the right answer, because what happens if they give me a string that is not in this array list, or in this array? So I need to make sure that I don't ever ask to see what's in a cell that there is nothing in. And how do I know that? I simply check to see, is the cell equal to null? So by checking to see if it's null, if I have allocated an object there in that cell, then it will return false. It is not equal to null if there is an object in there. If there is no object in there, it will return true. And as I wrote it, which I don't know why it suddenly refreshed my screen, if search list I equals null, which is a comparison, so if the array that I was passed in at position I, which is initially 0 but is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, if that is ever equal to 0, then whatever I put inside of here is what's going to execute. And what I'm going to do here is I'm going to return -1. Why am I returning -1? Because I randomly decided that this function returns -1 if it doesn't find the answer. All right, so that takes care of the circumstance that I'm looking in a cell or about to look in a cell that's not actually populated. The last thing I need to check is the search list at position I dot name equal to my target name? If they are, then I'm going to return I. Why I? Because I is the variable that is iterating through this list, and I have just realized that this is the correct cell, and what I had asked is it returns to me the index of where that particular name was found in the array. So the only thing that's left to do here is if I've made it all the way through the for loop and I didn't get an answer, then that means that I didn't get an answer. So I need to return -1 because there is no answer. Now, again, why am I returning -1? What is that all about? I mean, the indexes are from 0 to some number. Why -1? Well, that's why I chose -1. It's a number that can't be an index that I would know. So it's an easy way for me to tell that this is an error condition, that I looked through the array and I did not find it. It's not a compile error or a runtime error. It is just I didn't find it. So it is a successful error, if you know what I mean. I did exactly what I was supposed to do, and at the end of it, I came up with nothing. So I need to be able to tell my calling, whoever is calling me, that I have failed in my endeavor. All right, so that block of code should work, in theory. Where did I forget a semicolon? The type or namespace string could not be found. And where did I use the word string? I used it here. Okay, I misspelled string. Fantastic. Okay, we're still doing something crazy up here, so let me stop doing crazy up there. That's why things are failing. Okay, so let's go ahead and use this new whiz-bang method that we have written. So what I'm going to do next is I'm going to go look through my set of trophies and see if I have a trophy named best hair. So all I have to do is say, I'm going to call my method, which which is called find trophy. And I have to pass it two parameters, which is going to be my trophies, which remember is the name of my array inside of my main method. And I'm going to pass it a string that I'm looking for. All right. And what is this going to do? Well, it's going to return an integer, so I better store that integer somewhere. So I'm going to say int found index equals that call. All right, now what am I going to do with that? Well, if my found index is -1, then we know we had an issue. So at that point, we can say console write line and tell the user not found in your trophies. If we got anything else, then we're going to tell the user where it was. And you might remember you do a plus sign and then the name of the variable if you want to append a variable to a string inside of a print statement. All right, so that's going to chug through, and yet again, I forgot a semicolon. Line 26. Yeah, there it is. Sure enough. Okay, it said it found it at index 1. Great. So now let's go and search for best dressed. It says not found in your trophies, and that's true. I never made a trophy called best dressed. So that's a method that searches through an array and looks for a particular value. If it finds that value, it returns the index. This code is going to be posted up on the REPL account. So that is, again, repl.it/@endasullivan, ENDASULLIVAN, with capital E and capital S. So you can just go grab this code and play with it yourself if you want to. And that is how you search inside of an array, which is, I believe, what's happening here. Traversing an array using a for loop. Okay, so the last topic that we are going to cover today is with regard to traversing an array using a couple of different methods. So in our previous example, we used a for loop because we said we were going to iterate from the index 0 through index 10 or whatever the length of the array was. And that's a completely valid way to do that. Most languages have a built-in function that allow you to iterate over an array because it's actually a very common thing to need to do. In C#, it's going to be called Foreach. In Java, it's simply just going to be for with a slightly different syntax. And that's what's going to be shown in these next two slides here. So this is the example for C#. So this is what we did earlier. We said for I equals 0, I less than data storage.length, I plus plus, do whatever you're doing. The other syntax is, again, this is C#, for each trophy in data storage, do something. In Java, the syntax is for trophy t : data storage, do something. Other than that, the syntax is going to be the same. So I'm going to do the example again in C#, just so that we have another example here. So the first thing I'm going to do is I'm starting off with a brand new empty file. And I guess I will call this one CS1322 lecture 2 min-max average. You'll understand why in a second. So I'm going to start off and I'm going to create an array of integers. What is happening? All right. Things are being weird today. I don't know why. All right, so an array of integers. How do we do that again? We say int, square brackets. We're going to call it numbers equals new int, and let's say it's going to be of size 10. All right, so if I just did this, that will create for me, as I said before, an array that has 10 spaces that can each hold a number. I'm going to go ahead and set all of them right here on the line as I'm creating it, and that is done by passing it some curly braces with actual numbers in it. So I'm going to pick 10 random numbers. 8, 2, 4, 5. 4, 5, 2, 4, 6, 8, 9, 0. Sure. Did I do that right? Was that 10? Yes. All right, so if you put curly braces after the definition of the array and the initialization, after the initialization of the array, it will go ahead and pre-populate the array with those values. So to be clear, what I did is exactly the same as me going numbers at 0 equals 8, numbers at 1 equals 2, numbers at 2 equals 4. As you can see, what I did up here is a much handier way of doing that, but they are completely equivalent. So just wanted to show you that syntax. It makes life a little easier. All right, and that will be called initializing an array with values. All right, so what we're going to do next is we're going to write a new method, and we're going to try and figure out what is the smallest number that is in that list, and we're going to use that new syntax that we just saw. So this is going to be public static, and this is going to return an integer, and we're going to call this function min, and it's going to take in our array of numbers. We'll call it search array. All right, so we're just going to use that new syntax, Foreach. This is going to be an integer, so we're going to look at the value of each thing, and then we have the keyword in, and then we have the array. You don't actually specify the square brackets at the end of the name for the array in this syntax. It already knows that it's an array if we're doing this. All right, so what is value? Also, that's probably not the greatest name in the world, but here we are. Value is a variable that I just made up, and what's going to happen with this type of loop is that it's going to go into the first cell of search array, and it's going to assign the variable value whatever was the value of search array at position 0. Then it's going to go through the loop. At the end of the loop, it's going to come back up to the top again, and it's going to grab the next element out of search array and put it into value and go through the loop again. So value is, let's call it next value or current value. It is the value that is the next cell in the array as we go through. All right, so just to prove a point, I'm going to go ahead and print those out. Wrong language. Console.writeLine. Cell contained value, current value. That's what I'm calling it now. Okay, and I'm calling it current value because that's what I wrote up there. So my program is already running. What now? Methinks REPL has lost its mind. What is happening? I don't know what's happening. All right, I'm going to grab this block of code because inevitably when I refresh the page, it's not going to be there. And I'm going to refresh the page. Let's see where we are. I like to declare we are connected. All right, well, the block of code is there. Did it work? Let's see what we did wrong here. All right. No. Okay, REPL is being weird, but all right, so the error that it gave me is not all code paths return a value. The reason that it's saying that is because I declared this method to return an int, and then I never returned an int. And it can tell that I didn't return an int because I haven't actually done that. So just to make it actually compile, I'm going to return 1 for now, and we'll fix that later on. So hopefully that fixes that. It does. All right. So I'm going to go ahead and call this method because we are not currently calling it. So I'm going to pass it numbers. And it returns an integer, so I better return value equals that. Okay, so as this ran, the Foreach loop did exactly what I said it was going to do. It took the array, which we called numbers, from up here. Remember, we initialized it with these numbers, and it passed it into min. Min used this Foreach loop, took that same array, and then it goes through it one at a time and assigns a new value to current value, and then executes everything that's between the curly braces. So the first time through, it grabs the contents of the first cell, which was an 8. Second time through, it grabbed a 2, and then a 4, and then a 5, and so on and so forth. And you notice that I didn't have to do anything about the length of the array here. It just magically knew what to do with it because that's what a for each loop does, or in the case of Java, a for loop where you use that other syntax. It understands that we are iterating over an array, and therefore I don't have to do anything. All right, so the point of this was I was trying to figure out what is the smallest number in the array. So how do I need to do that? Well, probably what I would do is before I start going through the loop, I'm going to assume that the value that's in the first cell is the lowest value. So I'm going to say lowest, which is going to be an int, equals, I'm going to give it the first cell, search array at position 0. So pretty much what I'm doing is I'm declaring that the lowest is the whatever's in the first cell. And then I'm going to use this loop to actually validate that that's true. And in the end, instead of just returning 1, I'm going to return lowest. All right. So now each time I go through this loop, I'm going to say if the current value is less than lowest, then we're going to set lowest to current value. So basically, I'm setting lowest to whatever's in the first cell, which is the number 8. So lowest right now is 8. We're going to go through this loop, and each time through this loop, we're going to say, is 8 less than 8? It's not. Great. We're going to go back around to the top of the loop, and then it's going to say, is 2 less than 8? Yes, it is. So it's going to set lowest to 2. It's going to go back through the loop again. It's going to say, is 4 less than 2? No, it's not. Is 5 less than 2? No. Is 8 less than 2? No. Is 2 less than 2? No. Is 7 less than 2? No. Is 5? Is 9? And then eventually it'll get to here and say, is 0 less than 2? And in that case, it will go ahead and update it. Just so that we can actually see this running, I'm going to put in a couple of debug statements. And this is very common, especially when you're writing code and you're not entirely sure how to trace it in your head. A couple of debug statements go a long way. So anytime that I change the lowest value, I'm going to go ahead and print out onto my screen that I did that. All right, so go ahead and run it. And so as you can see, it went in and it looked at the first one, it looked at the second one and said, hey, that one actually is lower. And then it got down to the bottom and it said, hey, no, that one's actually lower. So in the end, this should have returned 0. I'm going to go ahead and output that in my main function. Semicolon. All right. So when we run that, lowest was 0. And if I change those around, so I'm just going to change that last number to a 3 and we rerun it, we should now see that lowest was 2 because the lowest number in there was a 2. So that seems to be working correctly. All right, so what I'd like you to do is pause the video, go to REPL yourself, and figure out how to write max and average. So max should return the highest value in the array, and average should return the average of all of the array cells. So go ahead and pause the video, go write that, and then when you're ready, unpause and I'll show you how to do it. All right, so hopefully at this point you have written that, and so I'm going to go ahead and type out the answer here. So public, I'm actually just going to copy this block of code because it's pretty much the same from min and max. So here we go. This time we're going to call it max. Takes in the same parameter. I guess I should call this highest instead of lowest. And we're we're going to return highest instead. And we simply have to say if the current value is greater than highest. And did I get all of those? Who knows? We'll find out in a moment. All right, I'm just going to call it to validate that it works. And in this case, it is going to be max. And we're going to write highest was return value. Cool. All right. Okay, yeah. Can't do that. Return value 2. Terrible variable name. Don't be like me. All right. So if I move this video window around here so we can actually see what happened, we get lowest was 2, highest was 9, and that does seem to match. I would say when you write some code and you want to validate that something is correct, just because you got the answer the first time, you should probably check that you actually really did get the right answer, not just by accident. And the way to do that is change one of the values in here to something that should trip, making it into the, trip the code to find it as the max. So this time through, we should find the max was 15, which it was. And we already checked the min by changing that to 0 or changing it to 3. And we did indeed get the lowest was 0. So anytime, and especially when you're doing your tests, and especially when you're submitting stuff in the lab, anytime that you've written code, just because you got the right answer the first time doesn't mean that it's always going to be right. So make sure you test it with a couple of different parameters. And you should always be kind of thinking in the back of your head, what number could I put in here that would completely mess this up? Is there a circumstance where I'm assuming that the first answer is, or the first cell contains the lowest? So if I put in different values in that first cell, can I somehow mess up the code so that it works differently? And the answer is no, that didn't actually seem to have an effect. It still found 0 because there was no change in what the lowest was as it went through. But those are the kinds of things you should be thinking. Anytime that you did something special, and in this case I used that first cell as the default answer, I need to check, is there some weird circumstance under which that's not going to work? And again, the best way to check it is just put a few print statements in there and actually play around with some of your input values to see what's going on. All right, so the other thing you were supposed to have written while you were paused, while I was paused, was something to calculate an average. So we're going to do public static, we're going to return, and this one a double average, and again it's going to take in an array of ints. I guess it's just my array at this point. All right, and we're going to use mostly that same syntax for going through the array, but this time we're going to calculate a sum. That's the first step in calculating an average. You need to know what is the sum of the numbers. So I'm going to say int sum equals 0 to start with, and then I'm going to go through each of my array's cells, and I'm going to simply say sum plus equals the current value. And then at the end, I need to know how many items there were in the array, because the way you calculate an average is you take the sum and you divide it by the number of elements. So there are a number of ways I could do this, but I'm just going to do it the simplest answer right now. I'm going to say num elements equals 0 to start with, and then as I go through, I'm simply going to increment num elements. And again, there's plenty of ways you could do this. And then the return is nothing more than sum divided by num elements. All right, so is that going to work? Well, it compiled. Did it give me a right answer? So we have double, call it average, my average, equals, what did I call the method? I called it AVG. All right, and what do we get? We get an average of 5. All right. That has one interesting thing that you will notice, which is I'm going to go ahead and set these to a predictable set. And again, this comes down to validating my answers. So I'm going to set this to 2, 2, 2, 2, 2, 4, 4, 4, 4, 4. Okay, so what is the average of all of that? Well, please don't do that to me again. All right, I'm going to pause the video and fix this. Hold on. Okay, one quick refresh later. All right, so where we were here is we were looking at the numbers and we were just trying to make sure, does this actually make sense? So by putting half of them to a 2 and half of them to a 4, I can know that correctly the answer is supposed to be 3. If you're not following along with the math, a bunch of 2s and a bunch of 4s, if there's an equal number of them, then the average is 3. You can certainly add them up yourself. So that would be 10 and this would be 20, so that would be 30 divided by 10 would be 3. Bing, all good. All right, so let's set it to something else. So let's set these to 5s. Okay, so I'm going to pull out a calculator here just so that you're aware of what's going on. All right, so there are 5 2s, which is obviously 10, and then there are 5 5s, which is 25. So 10 plus 25, the sum of the numbers is 35. If I divide that by 10, because there are 10 numbers, my average should come out to 3.5, right? Great. Let's run it. That's not what it says. It says the average is 3. So what's going on here? Well, this is a circumstance where it's not exactly intuitive as to what's going on. It seems like we did the math correctly down here, and just before we print out these answers, I'm going to go ahead and console.writeLine sum is, and show me the sum, and num elements is, and show me the num elements. So I'm doing this just so that I can make sure that, did I get the sum correct? Okay, so it says, wow, I could have done better with the space there. It says the sum is 35. I'm going to go ahead and move my stupid window. The sum is 35 and the number of elements is 10. So it calculated the sum correctly and it calculated the number of elements correctly, but somehow when it said 35 divided by 10, it came up with the answer 3. And you say, well, okay, it's an integer, that's the problem. But no, I actually very specifically asked it to return a double. So why did I end up with 3? I took 35, I divided it by 10, and I said I'm returning a double. Why is that not 3.5? Well, the answer is because, unfortunately, as I specified sum as being an integer and number of elements as being an integer, the divide operator thought that I was taking an integer and dividing it by an integer. And when you take an integer and divide it by an integer, the divide operator returns an integer. The fact that I'm later then passing that back as a double is simply a cast. So it calculated the number as an integer, and then it tried to return it as a double, but by then the damage was done. So, sorry, I randomly had to cough. At least I found the pause button. All right, so again, an integer divided by an integer is going to return an integer. And when it did the calculation, it came up with the answer 3 as an integer. It then tried to pass that back as a double, but an integer 3 passed as a double is still 3, 3.0 in this case. So how do we fix this? Well, the answer is one or both of the operands to the divide method has to be a double. So I'm just going to change both of them, because it doesn't matter. They're both just numbers. It's not a big deal. And now all of a sudden, I get back 3.5 because a double divided by a double is implicitly a double. And then when I passed it back as a double, nothing got lost. So that's a really weird bug that I could absolutely see you sitting at 3 o'clock in the morning, pulling your hair out, wondering why 2 plus 5 divided by 2 magically equals 3. So something to just be aware of, that when you're doing divide operations, and it's really mostly applicable to divides, you probably want to match the types that are coming out. There's one other way you could have solved that, which is to specifically cast, which is not something we've talked about here yet, but I could have also just come in here and said double, and that would have solved the problem as well. By putting parentheses around a type on front of a variable, you're casting it right there and then to that type. So what it did was it took num elements, which at this point in time has a value of 10, and it casted it from an int, which is what it is, into a double, then did the divide, but because one side of the operation was a double, the answer now is a double, and so we get the same thing. So that's a lot of detail of something that's random, but it is important when you're doing division, which turns out to be a common thing. Who knew? All right, so traversing an array, we talked about that. We talked about the new syntax. As I say, the syntax in Java is almost the same. It goes from for each to just for, and instead of the word in, you put a colon. So everything else would have been the same in the example. Just be aware that anytime that you call length, this is another one of these weirdnesses, Java uses a lowercase l and C# uses a capital L. So that's why that's in here. And the rest of the slides are just covering pretty much the same example that I went through today. So hopefully that was informative, and hopefully at this point you are back to being caught up on where you were in 1321. So we've covered most of the material that you probably tripped over in 1321. We're going to take it from there and start expanding upon that in Module 2, which we're going to cover starting next week. So again, as a reminder, if you haven't already done so, please go and take the quizzes. They need to be done this week. And if you have any questions, remember that my office hours are posted on the FYE website. They are also posted on the intro announcement on D2L for this page. They're down in here. There they are. So Tuesdays and Thursdays, I put one earlier in the day and one later in the day with the hope of that probably catches most of you guys when you're not in class. If neither of those work and you need to talk to me, then send me an email. We'll figure something out. But on those days, I will be hanging out in the Collaborate Ultra section, which you just come up here, you go to Other, and you hit Collaborate Ultra. And after that refreshes, it's going to pop you into a window, and there's a default classroom, and you should just be able to join the classroom, which you click on here, and bada bing, join course room. If you pop in there, that's where I'm going to be, and we can share a whiteboard, we can talk through video, and we can also exchange files back and forth inside of that. So I'm going to be in that session for the hour every week, just lonely all by myself hanging out. But if you have a question, or you have something that you don't understand, or you just want to chat, then pop in and I'll be happy to help you out. And other than that, I will see you guys next week in a new set of videos. I hope you guys all have a great weekend. See you soon.